Okay, so last class, just as a reminder, first of all, unless you previously had worked with me on an alternative, remember if you didn't do the hackathon, your paper is due by midnight tonight. The thing it's on Slack. In any case, remember that thing's worth 3 assignments. So if you went to the hackathon, you stayed the entire time, you you get credit for 3 assignments. If you left early, I posted up there that you have to do 2/3 of a page per hour you left before 7 p.m. and that's due by midnight Wednesday. So a couple people left, just a couple hours early, so you have to do a short history of VR thingy. But for those of you who did not do the hackathon, your paper is due tonight by midnight. And again, that's worth 3 assignments. That would be a very bad thing to miss. Okay, in any case, what we've been working with lately is we're starting to run into some challenges with our relatively weak environment, right? So we kind of reflect back on the current variable environment we have. What are some weaknesses that currently exist in the variable environment? Well, go ahead.
A bunch of 2 lists, so it's an environment that holds one variable extended in another environment.
Yeah, so we kind of have this problem where our current, when we create an extend env, we only can extend by one variable value pair. It doesn't seem very efficient, right? And actually causes some additional problems. Now, when we think about variable environments in real life, when we think about Java, we typically think about variable environments in terms of scopes, right? What do I mean by scope? What's a scope?
Like a part where a variable lives and dies.
Okay, so we might call this a collection of name value pairs that dictates where a variable is accessible. So at the end of, for instance, a function, the scope that was generated as part of that function goes away, right? Similarly, as part of like a for loop, the scope that was generated as part of that for loop goes away. We've seen that in Java where we say for int I equals 0, blah, 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 and then inside the loop we can use I, but right after the loop is done, I is dead. It's not a thing anymore, right? Right, so what we want to do is we want to go back and we want to reimagine our environment in terms of, let's call it an upgraded environment, where an environment is effectively, well, what I actually want to do here is I want to replace the word environment with scope. If you want to think about it kind of like our expression language we currently have, where we have a program, which is an expression, in that case, we can say an environment is a scope, where a scope is a collection of 0 or more. Well, a scope is a collection of name value pairs, so we already have that. And it's also a collection of 0 or more other scopes, right? And we've heard this phrase before that all variables resolve to their most local definition. And what does that ultimately mean? It means we check the most local scope first. Then we check that scope's parent scope, etc. So we just keep walking up until we run out of scopes that are in our tree. Okay? So if we kind of think about this, we can say that an environment starts off by having a global scope. All right. Now, keep in mind, we're not dealing with objects yet. So we're actually kind of just taking our language from, real ghetto language to procedural-esque programming language, that really just has local, inside of one file, let's say. That's not really procedural, but let's just call it that for right now. And then we'll have to upgrade it again when we want to think about objects. Okay, but let's just take it one step at a time. So when we think about a standalone Java program, so when you first learn Java and you have the class that has public static void main in it, that guy, that class, if we call that our environment, the environment that belongs to that class, comes with a global scope. All right, now let's say you had some other methods in there. So for instance, we had a main method. So living inside of this global scope, let me stretch this out a little bit. You have some other subscopes. So we had our main method. Let's just call this guy another method. Okay? And possibly inside of the main method, for example, we might have a for loop. And I can't do any more because we're going to start making things too skinny. All right, so that's kind of our model here. So we have this idea of our new environment, which is a collection of, well, our new environment is a scope. Later on, we might say an environment can actually have a collection of scopes. For instance, we kind of think ahead a little bit. When we create a singleton in Java, what do? We're creating another class and putting a whole bunch of static variables in it. So we need to have access to that class from within another class. So now you might have in your environment more than just one global scope. So that you have a global scope on a per class basis, where now you actually have another level of multi-class scope that would hold information about a whole bunch of classes that are whether they're accessible or not. Okay, we're not going there yet. For right now, we're thinking about Java in terms of a single file. Okay, a single class that has your main in it, and the only methods that you can write are things that live in there. All right, so we have that global scope. Then you might have your main method. So the main method lives within the global scope. Okay, so if you're in the main method and you're resolving a variable, you're going to check the main method scope first. If you don't find it there, then you'll bounce up to his parent and you'll check the global scope. After you check the global scope does not have a parent. So his parent scope would be null, right? Therefore, you're done. Your error. Did not find variable you're looking for. Now, even inside the main method, if we create a for loop, for int I equals 0, blah, 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 when we're inside of that for loop, that variable I resolves to its most local definition, which is the I that was defined as part of the for loop's scope. Now, the reality is that this scope is a little bit different kind of animal than this scope in modern day implementations. But for right now, let's just think of them as being identical. It's just another scope. It's kind of a lightweight scope. You might think of it, if you want to go from like an operating system's perspective, the difference between a process and a thread. So threads are lightweight processes. So there's not as much baggage that comes with them. So the scope that comes with a for loop is kind of like the thread version of a scope. It's a lightweight kind of temp scope, if you will. All right, so this main method has within it this for loop scope. So when I have a variable that's being used inside the for loop, I try to resolve it in the for loop scope first. Then if I can't find it there, I bounce up to that guy's parent, which is the main method scope. I try to resolve it in there. If I can't resolve it in there, I bounce up to the main method's parent, which is the global scope. If I can't resolve it in there, it's an error. From another method scope, see, another method lives inside of global scope, but is separate from main method here. I probably could have drawn this differently, but whatever. All right, so that means if I have a variable I'm trying to resolve inside of another method, if I don't find it there, another method's parent is actually global scope. Make sense? So that'll be the next place I look. I can't look in for loop, I can't look in main method because these two guys are separate scopes from another method. They just happen to live in the same neighborhood. They both live within the global scope, but they're separate from each other. That kind of make sense? So we need to reimagine our environment interface to be a collection, well, to be a top-level scope that then has scopes within it. Where a scope is maybe we look at a scope as being a list. So we can say our scope implementation. So for instance, we can have an environment containing a global scope at the most basic level. All right, and we might even decide to implement our environments as kind of pre-parsed things just to give us some information about what we're dealing with. So what we might do here is we might say that this guy is an ENV. Just so I don't have to quote it as much, let's just do that for the sake of this example. So we have an ENV. Inside that ENV, we have a scope. Okay. Now a scope will have a list of name value pairs. So maybe we have A5, B7, something like that. But then it could also have a list of additional scopes that live within that guy. All right, so now we have to think about this. So in our global scope, actually it's still in this thing. Here's my global scope. Inside there, my list of scopes is going to have two separate scopes, right? Now those guys are not related to each other. They both have the same parent, but this scope and this scope do not have anything to do with each other directly. Make sense? So that's why this guy would be a list of scopes. That's what this guy will ultimately be. So just to kind of give us an example there, why don't we go ahead and say something like we have a list containing a scope, and maybe this guy will have in it A7. We'll just make it a relatively small scope. All right, so here's the name value pairs. It's a list of two lists, and that's for that scope. And let's see that. This closes that. This closes that. This closes that scope. Then we have another scope in it that's in there, and maybe this guy has B8. So that closes the scope. That closes the list of scopes. That closes the outer scope. That closes the environment. So what this would do is this guy here is the global environment. So at the global level, we have an A is 5 and a B is 7. Then inside that, this might be like your main method right here. So inside main, you have a scope that has a variable A is equal to 7. So if we're inside of this scope, if we're executing an expression, if we're applying an expression inside of that scope, what are we doing? If we're trying to resolve the variable A, all variables resolve to their most local definition. So A would boil down to 7. But if I was living inside of this scope and I was looking for B, I would first try to find B inside this scope. When I don't find it, I would bounce up to this guy's parent. Who's this guy's parent? He's the owner of this list of scopes. So his parent is this scope, and he does find a B in there, currently equal to 7. This guy might be the another method from our example a few minutes ago. So another method and our main method are separate scopes that live next to each other inside the same neighborhood, but this guy's parent is not this guy. This guy's parent is this scope. So if we were to resolve B inside of another method, it would come out to 8. If we were trying to resolve A, it would come out to 5. Does that make sense? All right, so that would be an upgraded version of our environment. Now, in terms of constructors, so what's an empty environment? Because now that we've kind of picked a structure for our environments, we have to consider how do we build them? Because every single time we define a variable, we add it to the current scope, right? When I say int a equals 5 in Java, that variable is available from that point forward in the current scope. If I later on say int b equals 6, Now that variable b is available in the current scope from that point forward. Now things work a little different for us in Scheme because we don't have, at least at this point, we don't have this idea of a block structure yet. So when we think about Java, when we have an opening and closing curly brace, what is that effectively? It's a list of statements, a list of expressions, if we want to talk in terms of our current things. And what do? We execute them linearly. So we do this guy, then we do this guy. Now, if this is the variable definition, he's going to change the scope. I then might have some other lines of code in here that might refer to that variable. Then when I get to this, maybe this is another variable location, variable definition, maybe 5 or 6 lines down. That's going to update the current scope to add another toList to it for this new variable definition. So from that point forward, I now have access to that variable. Does that make sense? So we have this idea of like a list of expressions. In Java, it's called the block statement. Anything with the curly braces. All right, so an empty environment would look something like that right now by our current example. It's a environment that has a global scope with no variables in it. Make sense? If we wanted to give it a couple of variables, so let's just here, let's call this this is our empty env. That's what that guy is. So now let's say I want to add a variable to a scope. Well, if let's say I come in here and I'm like doing my apply program, and let's give this guy a variable name actually. Let's just call this, let's call it env. So there's my variable env is going to be equal to this scope-based environment. If I call apply program on some expression, passing it env as the environment in which to execute that expression. And let's just thinking ahead, let's assume that I can now define a variable. So somewhere in there, I'm going to say something like int a is equal to 5, or the equivalent. Maybe we have a call like define a is 5. All right. The idea here would be that this variable a gets added to this environment. But when we execute this program, aren't we actually executing it in terms of the current scope that it lives in? So maybe this isn't an environment. Maybe this is a scope. So the reality is what this guy is that guy right there. So he might look like that. What happened?
Liquid lunch.
Oh, hopefully it's full of sugar. Okay, so if I do something like define a, and I'm operating inside of this current scope, adding something to my scope is going to be going in here, getting the list of variables. Okay. Now you could always, if you wanted to, for your scope, if you wanted to further expound this and say this is, like the dictionary or something like that, for the name value pairs, you could do that. For right now, I think we have enough metadata in here to tell us what we're dealing with. So this guy is a list of toLists. It's currently the empty list. So if I want to add something to my current scope, that might look like this. But it also, let's see, I could have, let's take this a step further. Actually, that would be the empty scope, right? It's a scope with no name value pairs and also no subscopes. That's what the an empty environment is. So if I originally pass this guy in, and then for my scope, I have that. So when I'm defining, so if I'm applying program on this expression with this scope, and I define a is 5, my most local scope is actually this dude, isn't it? This would be like my global scope. This is the scope I'm currently operating within. So I would need to go and find that scope and add AN5 to that scope. Does that make sense? So if we had, let's just go into a Java program here real quick. If I had something like this, this is my top level scope. Here is the scope this is the first scope that's in his list of scopes for that top level scope. So if I come in here and I define this variable string my name, for example, the scope I'm adding that variable to is this scope, not the more global one. Actually, let me do something like public some func. Just do something like that. All right, so now there's two scopes that live here. We have our global scope that has this one variable in it called my name, and then we have this new scope called sumfunc. And so if I was sitting here, my current scope implementation would look like this. It would say, I have a scope that currently has a my name, and I'll just put the empty string on that for right now, just for no good reason. And that's a to list that lives in my list of name value pairs. And then I also now have another scope that initially has no name value pairs and has no subscopes. And he lives in the first bucket of my list of scopes here. So when I say int b equals 7, what I ultimately want to have happen is I want to add a toList b7 there. This is the scope in which I'm currently living. That make sense? But now, what if I then come down to this next line and I do something like system.out.println my name? It's static, so it's going to probably, well, actually, it's not going to complain because I'm currently in the class. I say my name. Well, if this is my scope, I'm going to look for my name in there and not find it. How do I get up to the next scope? So we have to think about how do we almost think about when we call an expression, we almost have to like load the gun with the scopes in the order in which they should be hit. So instead of passing it a scope structure like this, we could store our scopes like this, no problem. But when we go in to execute something, what we really need to pass them is we need to say, here is the most local scope. In effect, but also flattening it. So here's our most local scope. Here's the next global scope. That's where to check next. Does that make sense? That's where we're going to check next. So when I go to print out my name, I'm going to get the car of this guy and go through his list of to lists and say, is my name in there? If it's not, I'm going to burn past this and I'm going to get the car of the cooter. So I'll search again. So I'm probably going to have a function called like resolve variable, where I look at the car list. If it's not found in there, then I call search variable for the same variable, passing it the cooter of the list, because that's the next scope to search. So there's a difference between how we store our scopes and how scopes actually get searched. Now let's keep going with the Java thing here. It would have probably, just so I don't break this program too much, let me just pop open Eclipse. Okay, so we'll use this as our example then. So when we first call this guy, we have our list of scopes that exist here. And the first scope, now what I'm actually going to do is I'm going to represent my scopes as a list of two lists. So at the top level, do we have any global variables here? No global variables. So my first list of two lists is nothing. My next list of two lists is this current scope. This guy right here. So when we call this function, when we call main, the Java virtual machine calls main, right? He gets thrown the list of scopes, the list of name value pairs, or the list of two lists. So he gets something that looks like this. The very first thing main does is he creates his own more local scope, and he pushes it onto that stack. This guy has a stack of scopes. Okay, so we push that scope onto the front. So I'll just label them here for a second. So this is main scope. This is driver's scope. Now, as of right now, at this line of code, there's nothing in those, right? They are empty scopes. So now, when I hit s is equal to hello, I'm going to go ahead and I'm going to expand main scope to have in it the to list s hello. Then I hit s2 is equal to hello. So I'll expand main scope to s2 is hello. Might as well just be complete. S3 is hello. So here is the list of two lists associated with the most local scope. And just for the sake of argument here, I'm going to come up here. I'm going to say static int a is equal to 5. So then what we'll do down here is we're going to have a is 5 in that guy. All right, so my first list of two lists, that's my most local scope. So when I come right here and I say system.out.println, let's just assume S, okay, that we're printing out S. It's going to pop the current scope off here and look through it, resolve S. And it's going to find S right here, and it's going to resolve it to hello. Okay? And then it'll push that scope back onto the list. Still the most local. The very next line, if I do system.out.println a, I need to resolve the variable a. So I'll pop my most local scope off, and I'm going to look for a in that guy. When I don't find it, what am I going to do? I'm going to pop the next scope off. Now, you might always want to work with a copy. We have a list of two lists. You might want to create a, maybe, well, if you have it in another function, you'll pass it into the function. When you change it inside that function, it's not changing the original. So if you have a function called like resolve variable and you pass it this list of, let's call it list of scopes, you can then pop things off that list of scopes to your heart's content. And you're not going to break the original one that you sent it. Scheme doesn't work. We don't have the idea of a pointer in Scheme. Okay? So we can do that. So when we go to print out A, we're going to pop off the first thing, which is effectively get the car of that list of scopes. We'll look through there. We'll find the S in the previous line, but now we're looking for A in there. We're not going to find it. So what do? If my list of scopes is not null, I got more stuff, we pop the next scope off. So now I have this list of 2 lists, and I happen to find A in there, it resolves to 5, and I spit that answer back out. Make sense? So within a particular scope, a scope has to know about his lineage, where he came from. So we need to have the ability to extend the current scope with another scope. So if we come back into our planning here, and we're thinking about what a scope structurally is. Actually, let me keep it in here. I think it'll look cleaner in here. This scope might look like that. Whereas this scope, I'll just go down the first line of it, is going to, there's my list containing my list A5. And then before that, I'll push on a new empty scope. And then inside the empty scope, I'll add a count is 0 pair, like that. So when I am executing, when I'm applying expression on this scope, this is the list of scopes I'm working with, the stack of scopes I'm working with. If I'm applying expression in this scope, this is the stack of scopes I'm working with. When we add something to a scope, what am I going to do? I need to add a name value pair to the most local scope. What's the scope I'm adding it to? So when I originally had this, let's say I was, let's say I had that S1 or S and S2 already. I get to this next line, S3, I need to add a variable. I may be going to have a function called addVar that takes in a scope and a var name and a var value. And that guy will return the scope extended with the new var name and var value. So if I were to pass that guy this, he would, so for example, if I passed it that scope, he would ultimately spit out. You can decide whether you want to add to the end or add to the front. Add to the front is going to be easier. You can just cons it on there. Actually, it doesn't matter. You can cons onto either side. So we'll return S3 hello as a 2 list, cons onto the front of my old list. This is the now updated scope that addVar will return that I'll then push back onto my existing stack. Make sense? All right, so our new stack interface. And when we think about stack interface, this is how do we represent the stack of scopes in which an expression is being applied. So we can mark them up if you want, but as long as you can remember that a scope is a list of 2 lists. Or a list of 2 lists is one scope, and we have a stack of those things. So we're going to say that our stack interface is scope interface is a stack of scopes, where a scope is a list of 2 lists representing name value pairs. That make sense? So as we pass around this stack, instead of passing around our old environment, which is our extendienvs and things like that, when we pass around this stack, whenever we are moving into a new scope, we will cons an empty scope onto that, and then that becomes our updated stack of scopes for that new expression. We can now update that stack of scopes and work within it. And at the end of a block, at the end of a function, whatever, which we don't really know how to represent yet in our language, but the idea would be at the end of our program, all those scopes die. But when we're executing a specific line, we only have the scope that existed that time through it. Okay? So what we want is we want some constructors. So we want to be able to create an empty environment. Actually, let's call this just so we don't have conflicts with our current environment interface. We'll call this an empty scope. So an empty scope is going to be a list containing a single scope. Actually, we could just represent it as an empty list. We'll do this. That's an empty scope. Empty scope is the empty list. And we're going to have a list of scopes, like we mentioned up here, or a stack of scopes. So our stack of scopes is going to be a stack of, at the bare minimum, those guys. Right, so that's our empty scope. Now we need to have functions. Add scope that takes a scope, a var name, and a var value, and returns an expanded scope with the new toList added. All right, that's all add scope does. Add scope creates a expanded scope. As an example, if we called add scope on the empty scope, passing it A5, this guy would produce the scope containing the single toList A5. It'll expand that scope that currently has 0 variables in it by adding 1 more variable. If I were to call add scope on this guy, B7, this would produce the list A5, B7, or it could be B7 then A5. You can decide whether you're consing onto the front or consing on the end. Doesn't matter. That makes sense what add scope does? Add scope adds a name value pair to a single scope. So this guy right here, the scope this takes in as a parameter, is a scope, a list of name value pairs. One scope, not a stack of scopes. Resolve var will take in scope stack and the var name we are resolving. And this guy should return the value of the most local definition of var name in the scope stack, or false if not found. For example, resolve var on the list containing that guy and the list containing that guy, passing it C would boil down to 3. I'm going to add one more 2 pair to this. This one, if I passed it a B, its most local definition of B is 7, not the second one, which is 3. Make sense how those two functions work? One of them resolves a variable in a stack of scopes. The other one adds a variable to a flat scope. What else do we need to be able to do with scopes? What about adding more than one value to a scope? Is that something that's going to be handy? When would that be handy? When would it be handy, for example, to add 3 variables to a scope? Maybe when we're implementing a let. If you have a let A equals 1, B equals 2, C equals 3, that let's going to have a brand new scope inside of it, and that scope is going to be the result of adding A, B, and C to that guy. Make sense? Go ahead.
Looking at that second resolve variable.
This guy?
Yeah. So when you're going through the list, it will give you the variable associated to be the first time, not the second time.
Correct, because this is in our scope stack, the pop of that scope, the car of that scope, is our most local scope.
Okay.
And if we don't find it in there, then we pop the next scope. Okay, so for our homework, and we were just thinking ahead for when we might want to add multiple scopes. We could certainly call add scope multiple times. For our homework, we're going to write add scope, just add a single name value pair to an existing scope, and we're going to write resolve var. That takes in a scope stack. Make sense? So write those 2 functions for your homework, and I'll copy that stuff into the assignment box. Questions, comments, concerns, bribes? All right, should be pretty easy once you make sure you understand how our scopes work.